Imagine our planet, teeming with life, a vibrant world far older than the dinosaurs. This was Earth, 252 million years ago, during a time we call the Permian period. But this ancient world was on the brink of a cataclysm so profound, it would nearly extinguish life itself. This wasn't an asteroid, a cosmic collision from above. No, the killer came from deep within the Earth. This is the story of the Siberian Traps and the Great Dying, the most severe extinction event our world has ever known. So what exactly are the Siberian Traps? The name might conjure images of elaborate snares in the snow, but the reality is far more immense. Traps comes from the Swedish word for stairs, describing the step-like layered hills of volcanic rock that cover a vast region of modern-day Siberia. But these aren't just any hills. They are the remnants of one of the largest known volcanic events in Earth's history. We're not talking about a single volcano like Mount St. Helens or Vesuvius. We're talking about a colossal flood basalt province. For roughly 2 million years, fissures in the Earth's crust tore open and spewed an unimaginable volume of lava. Let's try to wrap our heads around the scale. The Siberian Traps eruption unleashed enough lava to cover an area the size of Western Europe, or the continental United States in molten rock, in some places several kilometers deep. The total volume is estimated to be somewhere between 1 and 4 million cubic kilometers of basalt. To put that in perspective, 1 cubic kilometer is enough to fill 400,000 Olympic-sized swimming pools. Now multiply that by a few million. It was a planetary-scale hemorrhage of magma, an inferno that bled out from the planet's core for millennia. It literally paved over a continent with fire. But the lava flows, as devastating as they were locally, weren't the main killer. The real weapon of this mass extinction was invisible. It was the gas. As this superheated magma surged through the Earth's crust, it didn't just pour out onto the surface. It cooked its way through vast ancient deposits of coal, limestone, and other organic-rich sediments buried deep underground. This process, known as contact metamorphism, acted like a planetary-scale pressure cooker, vaporizing these deposits and releasing truly biblical quantities of greenhouse gases and toxic compounds directly into the atmosphere. The primary culprit was carbon dioxide. The eruption and the cooked sediments injected trillions of tons of CO2 into the air, far more than humanity has released in its entire existence. This triggered a runaway greenhouse effect. The planet's thermostat was broken and the temperature began to climb and climb and climb. Global average temperatures may have soared by as much as 10 degrees Celsius or even more. The poles, once temperate, became hot. The equator, already warm, may have become lethally hot for most complex life. But CO2 wasn't the only problem. The eruptions also belched out immense clouds of sulfur dioxide. When this gas hits the upper atmosphere, it reacts with water to form sulfuric acid aerosols. Initially, these tiny droplets act like a global sunshade, reflecting sunlight back into space and causing a brief period of global cooling. A volcanic winter. This sudden cold snap would have been a massive shock to an ecosystem adapted to the warm Permian climate. But this effect was temporary. The aerosols soon rained back down to Earth as potent acid rain. Imagine a perpetual, planet-wide downpour of battery acid. It would have stripped forests bare, poisoned soils, and acidified freshwater lakes and rivers, making them uninhabitable. After this initial chilling phase, the long-term heating from the CO2 took over, creating a devastating 1-2 punch for life on Earth. First freeze, then fry. And the horrors didn't stop there. The volcanic brew also included chlorine and fluorine, which once in the stratosphere, would have gone to work destroying the Earth's ozone layer. Without this protective shield, lethal ultraviolet radiation from the sun would have flooded the planet's surface, damaging DNA and making life on land even more precarious. The oceans, home to the vast majority of life at the time, faced their own unique apocalypse. As atmospheric CO2 levels skyrocketed, the oceans absorbed a massive amount of it. This is a basic chemical reaction. CO2 plus water equals carbonic acid. The seas became increasingly acidic, making it difficult or impossible for marine organisms like corals, brachiopods, and mollusks to build their shells and skeletons from calcium carbonate. The very building blocks of their bodies dissolved around them. The vast, intricate reef systems of the Permian, which were even larger and more diverse than today's, collapsed entirely. They simply vanished from the fossil record. The rising global temperatures also heated the ocean's surface waters. Warmer water holds less dissolved oxygen, creating a suffocating environment for marine life. But it gets worse. This warm, oxygen-poor layer on the surface acted like a lid, preventing oxygen from circulating down into the deep ocean. This led to a condition called anoxia, a complete lack of oxygen. In this stagnant, toxic water, a different kind of life thrived, anaerobic bacteria that produce hydrogen sulfide, a highly poisonous gas. Imagine the oceans turning into a toxic soup. This hydrogen sulfide would have built up in the deep sea, and eventually, it's thought that massive burps of this poisonous gas could have erupted from the ocean into the atmosphere. Hydrogen sulfide is not only deadly to breathe, but it's also another potent greenhouse gas and is destructive to the ozone layer. For any life on the coasts, the air itself would have become a poison. Some scientists describe a chilling image, a sickly purple or green ocean, belching death into a hazy, scorched sky. The result of this multi-pronged environmental assault was nothing short of an ecological collapse. We call it the Permian-Triassic extinction event, or the Great Dying, and for good reason. The numbers are staggering. Over 90%, perhaps as much as 96% of all marine species were wiped out, gone. The trilobites, which had survived for over 270 million years, finally met their end. The sea scorpions, formidable aquatic predators, vanished forever. On land, the devastation was nearly as complete. Around 70% of terrestrial vertebrate species disappeared. This included the dominant proto-mammals of the time, the gorgonopsians, fearsome, saber-toothed predators that ruled the Permian landscape. Forests were wiped out, replaced by hardy, scraggly disaster taxa like fungi and lycopods that could survive in the poisoned soil. For millions of years, the Earth was a ghost planet. The intricate food webs that had taken eons to build were shattered. The fossil record shows a coal gap, a period of millions of years where no coal was formed, simply because there weren't enough forests left to create it. Life was reset. The survivors were the small, the hardy, the generalists who could scrape by in a ruined world. Among them was a small reptile-like creature, Lystrosaurus. This pig-sized, beaked herbivore somehow managed to survive, and in the empty world that followed, it became the most common terrestrial vertebrate on the planet, accounting for up to 90% of all land animals in some areas. Life eventually did recover, but it was a new world, dominated by new players. The extinction of the dominant proto-mammals and other groups cleared the stage. In the ecological vacuum that followed, a new group of reptiles began to diversify and grow, eventually giving rise to the giants that would rule the planet for the next 150 million years, the dinosaurs. The Great Dying, in a very real sense, paved the way for the age of reptiles. The story of the Siberian Traps is a terrifying, yet crucial reminder of how intimately life is tied to the stability of our planet's climate and chemistry. It shows us how a geological process, a surge of heat from the Earth's interior, can trigger a catastrophic cascade of atmospheric changes, ocean acidification, and biospheric collapse. It is the ultimate cautionary tale written in stone and fossils, demonstrating the fragility of life when a planet's life support systems are pushed past their breaking point. Thank you so much for joining me on this journey back in time to witness Earth's greatest catastrophe. It's a humbling story, but one that gives us a profound appreciation for the resilience of life and the delicate balance of the world we live in today. If you found this journey fascinating, please hit that like button and consider subscribing for more deep dives into our planet's incredible history. We'll see you in the next one.